the photoelectric effect. This is an experiment that demonstrates light behaving as a particle. We can demonstrate light behaving as a wave in many ways, by reflecting it, by refracting it, and by diffracting it, such as in Young's double slit experiment. But this experiment shows us that light in some instances behaves as a particle. So first of all, let's explain the experiment itself. So we've got a gold leaf electroscope. These three pictures show the gold leaf electroscope in three different states. The gold leaf, very thin piece of gold foil, is here. In each instance, it's given a charge. Positive or negative, positive and negative. So this scenario is true whether it's positive or negative. This is true when it's positive, and this is true when it's negative. So the gold leaf is repelled from the central strip of the electroscope because they have the same charge. So here, whether positive or negative, they've got the same charge, so they repel. Here, they're both positive, they repel. Here, they're both negative, so initially they repel. So the idea behind the experiment is to discharge the gold leaf and have it return to its normal position. To discharge it, we need to get rid of the charge. So if it's positively charged, we need to add electrons to bring it back to neutral. If it's negatively charged, we need to remove electrons to get it back to neutral. And that requires energy. So by firing light at this zinc plate on top, we're supplying energy. So there are a few ways that we could increase the energy. We could increase the frequency of the light by changing it from red to violet to ultraviolet. Or we could increase the intensity, just make the light stronger. So if light behaved as a wave, we could achieve discharging of the gold leaf electroscopes by either of those methods, by either shining much brighter, much stronger red light, or changing the frequency. So if light was behaving as a wave, that would be true. But no matter how strong this red light is, we never get the photoelectric effect. We never discharge the plate and the gold leaf electroscope by firing red light. If the plate's positive, we don't get the photoelectric effect by firing ultraviolet light. We don't add electrons in this way. But if the plate's negative and we fire ultraviolet light, even if it's not particularly high intensity, the leaf falls back down immediately. This immediately loses its charge because the ultraviolet light releases electrons from this system here. So that suggests that light is behaving as a particle. These particles are having a one-to-one interaction. One particle of light, one photon, is having one interaction with one electron. And each particle, each photon, must have enough energy to remove one electron from this system here in order for the photoelectric effect to occur. So just to recap, if light was behaving as a wave and we just needed to increase the intensity, increase the energy, we could just turn the intensity up and we'd get the photoelectric effect. But we don't. It only occurs when we shine high frequency light, regardless of intensity, at a negatively charged plate. Therefore, in this instance, light is behaving as a particle.